Hello, welcome everybody. Here's your lesson on section 3.1, parallel lines and transversals. Let's start by going over a little vocabulary. So parallel lines are, lines that end up never meeting. So if you had two lines that were parallel, obviously you probably know a lot what this is already. These two lines right here are parallel lines. They're kind of like railroad tracks. Lines that go on forever, but they will never intersect. This picture here, line M and line N, are two parallel lines. Now, what's a transversal? A transversal is another line that will cut across those two parallel lines. So the parallel lines in the big picture here are horizontal, where these are not quite vertical, but they're somewhat vertical. And then a transversal like this could be any sort of line that cuts through those two lines. Now, if your lines are actually parallel, you have to have what we call parallel marks. Now, there's a couple different ways to do that, and it depends on the book you have. Some books will mark parallel lines like this, and some books will mark parallel lines with a little triangle like this and kind of fill in that triangle. So I'm going to probably use this kind of notation all the time when I'm talking about parallel lines. So this is your vocabulary little lesson on how you designate parallel lines. Just like angles will never assume that they're equal unless they have the little equal marks or congruent marks, with parallel lines we can never assume that they're parallel other than having those types of marks. Alright, parallel lines occur all over the place in the real world. So here are just a couple different pictures for you. I'll kind of go through these little pictures and talk about them. So I'm going to enlarge them and talk about each one. So here is an example of what the inside of many walls behind the drywall looks. And as you can see here, I'll use a laser pointer. Here you have these parallel markings, parallel wood studs is what they call. And then you need some sort of supporting brace. This is done a lot in architecture to try and make sure that those walls are a little bit more secure. There are actual regulations for this, so you can make sure you have to have this supporting beam depending on how long your wall is. Then we got a couple other different pictures here. Roads, of course, can be parallel to each other, and there's another road that cuts across, and then these angles that we have in here, each one of these angles have a little bit different properties that we're going to get into later in the chapter. And then here's another picture of cars on an angled parking lot where you're looking at these different little areas where the car pulls into, and then these little guidelines here all have to be parallel. Or else, obviously the cars won't be able to kind of fit in there normally. I'll come to that one last. Here's another example where you have a railing, like a support railing when you're walking up a stairs or a ramp, and then you got these little supporting beams that go into the ground or the floor, and those are all parallel, and then this could be a transversal, and you can kind of see this situation that we're going to be consistently talking about throughout the chapter. And then lastly, one of my favorites, this is an air hockey table. It doesn't have to be an air hockey table. It can be a regular hockey arena, rink. It could also be a like a billiard table if you're playing pool. And there happens to be different kind of shots you can make to try to bank a puck, if it was hockey, over to your opponent. And there's lots of different properties. And as you can see, as we run through this, this and this are two parallel lines, so when you shoot the puck and bank it off of here, it'll come, and this would be like a transversal, cutting this and this parallel line. So think about that in the real world ramifications of all these situations that we're talking. Here's some key vocabulary words, and feel free to stop this if I'm going too quickly for you. So let's start with, and I'm going to go back to my good old lightsaber because that is my favorite. Let's talk about, there we go, parallel lines are coplanar lines that do not intersect. I kind of said that earlier on. This is the parallel symbol. That is similar to a symbol like congruent. So you could have angle BCD, which would be the same size and same shape, congruent to angle XYZ. So the congruent symbol means same size, same shape, or you could have lines, like line JK, and then this symbol right there would be a parallel symbol. Different symbol than congruent means a different thing. It just means that those two lines are parallel. And notice here that I have these darkened triangles signifying the arrows are used to indicate that the lines are indeed parallel. Skew lines are lines that do not intersect and are not coplanar. Okay, so here's an example of a line in this upper level plane. Think of it like a table, and then there's a line on the table. And then this could be like the floor. These lines don't intersect, but yet they're not in the same plane, so that's kind of called skew lines for a situation like that. And parallel planes are planes that, planes do go on forever. They're planes that are just parallel. Here's another situation you'd have here. Now, in reference to the angles that you see here, all of these angles here and all of these angles here, anytime you have two lines, M and M, and you have this other line cutting through them, we call that line the transversal, you're going to have a set of 8 angles. Now, if you want to look, let's start with 3, 4, 5, and 6. 3, 4, 5, and 6. Now, if this is an in-class activity, I'd ask you to make up some names for the lines that are in this area of the parallel lines. So I'd eventually lead you to a vocabulary word called interior. These are all your interior angles. Okay, 3, 4, 5, and 6. Let's look at 1, 2, 7, 8. So I'll change colors here to red. These guys that are out here, 1 and 2, and 7 and 8 that are out here, these two angles right there, they have names too. Well, let's say these are interior. Guess what? These are exterior angles. Now, 3 and 5, I said earlier, were interior angles, and they are. Well, how do we designate the fact that they kind of jump over this transversal? Well, we'll call those still interior angles, and I'll abbreviate this because I'm running out of room, but they seem to flip over this line. So instead of calling them flipped interior angles, we call them alternate. And I ran out of room, so let me kind of put the whole word here. Oops, let me start with alternate because it usually alternate appears first. A-L-T-E-R-N-A-T-E, alternate interior angles. And those are 3 and 5. That's a pair of alternate interior angles. You could also have angle 4 and 6. They go together too because they jump over that transversal also. Well, what about 1 and 8? Changing colors to black. Here's 1 and 8. Well, 1 and 8 seem to be on the same side of this transversal. So some books will call them same side interior angles. Or I'm sorry, these are not interior. These are on the outside of the parallel lines. So that would be same side exterior angles. And that could be 1 and 8 because they're on the same side. Or it could be 2 and 7. And, you could probably figure out the rest of this too. Then if you talked about these two, they would be same side interior. And then these two right here, 2 and 8, would be alternate exterior. So using your words alternate or same side and interior or exterior. And the thing that I want to say real quickly about interior is this is the interior because it's in the alley between the two lines. Now we'll go a little bit faster. Interior angles, I explained those. So now let's look at this situation here, which is kind of like a little peninsula maybe with some water out here. And this is like the edge of maybe like a beach, and this is the other edge of a beach. These are your two lines, and this is your transversal. Now the weird part of this is the lines aren't parallel. And the lines do not have to be parallel to use all of this vocabulary words. It's the same thing. So interior are 3, 4, 5, and 6. They're on the inside in this green area. Exterior are 1, 2, 7, and 8. 1, 2, 7, 8. And then alternate interior, like I explained, would be 3 and 5. Look at your picture. And 4 and 6. Alternate exterior, look at your picture. Process what I'm trying to tell you here. 1 and 7, 2 and 8. Now, corresponding is a little bit of a tricky word here. Corresponding, I'm going to get out my eraser here, and I'm going to kind of erase a little bit of this right in here, and I'm going to talk about this in red because this is kind of a very important topic. So if I'm talking about corresponding, let's look at it. 1 and 5. I'm going to do this one and this one. 1 and 5. I wonder how we could pair those up. Let me do blue with 2 and 6. 2 and 6. Let me do black with 3 and 7. 3 and 7. And I'll leave the other ones blank, 4 and 8. So can you see what the pattern is? If I pick up these 4, place them on top of these 4, that's what we call corresponding. And I used same side on the last slide. Some books, like ours, will use consecutive. Consecutive means on the same side also. So I don't mind if you use consecutive or same side, as long as you know they mean the same. All right, we're almost done here. Now here's 2 examples to kind of run through this. We'll do an example of having a little box here, rectangular box. List all segments. So a segment that's parallel to segment CG. So I'll darken that in black. That's CG. I wonder which ones are parallel. If you want to stop it and take a guess, go ahead. Okay, this one would be parallel to CG because it lies in the same plane. This one would be parallel to CG because it lies in the plane on the side. This one lies in the plane on the front. FG would not be because it intersects that line. What about this one way over here? Well, let me ask you, is this in the same plane as this one? Well, it's not. It looks parallel of some sort, but it's not in the same plane. We call that skew. So AE would be skew to CG. And these are segments, so I need a segment bar over the top. Let's go back to the first one, parallel, because I never answered the question. Parallel to CG were these 2 thin red lines. So BF, same plane, parallel, never intersects. And DH, a different plane, but still this shares the same plane as CG. List a plane perpendicular to plane FGH. Well, I'm going to use black here. FGH, FGH. Let me do a little erasing here because there's a lot of marks on this. I don't want to be confused. So let's start with finding plane FGH. FGH. That would be this bottom platform. Now I want a plane perpendicular to it. Well, the plane perpendicular would be this polka dotted plane. I'm sorry, that would be a parallel plane. Perpendicular. Oh, it wouldn't be that one. So let's erase all those dots. And let's go with the perpendicular plane. Well, this one here, polka dots. They would form a right angle with the bottom face. Or this plane over here. Or the front or the back. So I'll just list one of those planes. I will list the left side plane. So I'll say plane, and I need 3 points to determine a plane. HEA. HEA. And that would be this side polka dotted plane right here. I could have listed any one of those 4 that form the sides of the box. All right, last question, number 2. Classify each pair, so I need a pair together, as alternate interior. So down here I'll go AI for shortcut. Probably should write it out when you're doing your homework. Which pairs are alternate interior? alternate exterior, corresponding, and consecutive interior. Okay, so let's start with 2 and 6. Let's look at 2 and 6. Here's 2, here is 6. Now, the trick here is these lines, the two lines are not parallel. Can you identify the transversal? I'll put a T by the transversal. This would be your transversal line right there, because that line is not the two lines, it's the cutting the other two lines. I'll put in blue the lines that you're talking about when you're determining interiors and exteriors. Normally you got two parallel lines cut by a transversal, but the lines do not have to be parallel, so that's why it's these blue ones. Can you see the interior? The interior is this polka dotted area because it's inside those lines. So how do I do alternate interior? Is 2 and 6? No, 2 and 6 are not both on the interior. Okay, what about 1 and 7? 1's over here, 7's over here. Those are not on the interior. Nope. 3 and 8. 3 and 8 are on the interior, right here and right here, but do they alternate sides of this red transversal? No, they do not. They're on the same side. I bet it's 3 and 5, and it is. So alternate interior are angle 3 and angle 5. Alternate exterior, that's an E there. Alternate exterior, let's see, so I did this one. So 3 and 8, nope, those are interior. 1 and 7, there we go. 1 and 7, they're on the exterior and they alternate the red line. So angle 1 and angle 7. What about corresponding? Okay, so I did this one now. Can pick them up and put them on top of each other. So let's see, 1 and 7. Oops, I did 1 and 7. I crossed off the wrong one. My bad. That one's still in play. Okay, so let's see, 2 and 6. 2 and 6. If I pick up these 4, put them on top of those 4, 2 would lie on 6. So angle 2 and angle 6. Consecutive interior, well, that's got to be 3 and 8. Let's just double check that they're interior, 3 and 8. Yep, polka dotted area. And they're consecutive, means on the same side of the red line, and that is true. And there you go, ladies and gentlemen. Those are your notes. Once again, it's geometry, so it's all about the vocabulary. Thanks for listening.